Good morning. I hope everybody had a great Easter. I appreciate everybody joining with me in prayer. I want to make a quick announcement that Kurt Yingling's mom is coming out of the hospital today after open heart surgery. So a lot of appreciation out there to you guys for praying with us. And Kurt is very, very thankful to everybody for praying for his mom. So thank you for that. So after that, I may as well just go ahead and open up with a prayer, and then we'll start in. All right? Father, thank you for this time again this morning, for us to practice our craft, to learn our craft better, Father, and most importantly is just to do our jobs safer, Father. The people in our industry, a lot of them put themselves in harm's way to serve others, and which is something we don't see a lot of in this world today. So lift all those folks up, keep them in your hand, Lord. Watch out for them. Also lift up our government, the craziness that's going on right now, and being able to do the best for our country with this pandemic going on. And I just hope that everyone will follow the guidelines and be careful. I think now people are starting to hear more and more about folks that they know or have heard of that have it. So let's just be mindful out there. And most of all, just thank you for the safety you put over us every day, Lord, and for keeping us in your hand, and for that sacrifice that your Son made, so I can pray right now. So all of these things I ask according to the will of the one who paid it all, my brother, Jesus Christ. Amen. All right. Let's go over our the agenda. This is the next in the series of the COVID-19 series that we're doing. We're going to go over 5S today. Got a lot of interesting things to do. As we know, 5S throws you a lot of curveballs. It's the one that you can learn a lot about in the field, or that you want to probably drop kick out in the middle of the field most of the time. So we're going to go over all that stuff today. Thursday is going to be another new service that we're providing at PowerMetrix. So please tune in for that. And then we are taking your suggestions to heart. Okay, we are actually going to run some tests that some people have asked for next week. So please send in those suggestions of what you might want to see. Meter forms, particular tests, because we will put those in there. We're running one today, as a matter of fact, that was sent in as a request earlier. Let's talk about what we're going to cover today. We're going to talk about connecting the Powermetrix to a 5S service. We're going to talk about verifying the site accuracy under field conditions. We're going to do some troubleshooting. We've got some scenarios that we're going to use off of the bench to throw me curveballs. We're going to do things like you got phase fault, missing the primary current. We've got polarity reversals, both on primary and on secondaries. We've got some cross phasing. And then, as asked by one of you viewers, we're also going to take a look at the single phase 3-wire setup, and a couple of error scenarios on that as well. Okay? So we can go ahead and get started. Okay, we have our 5S meter right here. And I'm going to say this one time now, and remember this for later when we're doing some of these tests, because it's going to be important. I have a 5S meter here that is not bidirectional. Okay, that's going to be important here in a little while. So I've already got my pickup connected right here. So I'm going to go ahead and make my connections. Yeah, sorry about that. You know me, I talk to people, so I keep looking over and wanting to talk to Chris and Jared instead of the camera. Okay, maybe put a smiley face on top of it or something. Okay, so anyway, they even put me a little piece of yellow paper on top of it, so I look. I said, how about a feather? Nah, that didn't freaking work. Okay, so let's go ahead and make our connections, okay? So I'm going to come in here. We always say connect our neutral first, right? For our voltages. So I'm going to make my neutral connection there, and then I come here, and this is A phase right here. And then I can see right here, so that you guys can see this, I hope. This is my shunt. That's my return. So here's my next voltage right here. So I'm going to connect B phase right here. Okay. All right. And then I've got C phase. I've got shunt and return on C phase. And then here would be my C phase voltage. So I'm going to come right here. Connect right here. All right. All right. So then I'm going to remember this is a delta, so we're going to be on A and C phases, right? My current, so I've got my A phase duct bills going in right here. Close in my return to complete the circuit. Current flowing. Now I've got C phase over here. Put in right here. And close in my shunt. Okay? So I've got my pulses picked up here. I've got my secondary voltages, and I've got my secondary currents. So I should be good to go. Okay? All right. So we're going to go in here, and we have got a 5S delta site entered in here. So we're going to go off that 5S delta site, and we're going to hit 2 for an integrated site test. So everything looks good here. We've got the site, we preloaded the site in here, so we've got it set up. So I'm just going to go ahead and hit next. I didn't have to worry about double wrap, checking my double wrap box because I do not have my wraps double wrapped. So I got them single wrapped. So I look here, this shows my color diagram. So we can hit next. So my vectors look good, right? So I'm going to hit continue. And I'm going to back up for 1 second. Here, when we come up on some of these other tests, you're going to see, you know, if you see really squirrely vectors, and Chris Mullins made a good point the other day to me. He said, when you're doing this, you know, it's like forensics. If you've had any training from me, you've heard me say that before. It's like we're forensics guys out there. So first we see a vector, and it's jacked up. Okay, now why? What's the problem? And sometimes you got to back out and take a look. You got to use this up here, and you got to think about how many voltages and currents I've got and what's going on, and then it can explain some things to us as to why we can't test, you know, we'll be standing there forever waiting on a pulse or other things. We're going to get into that in a minute, but just right now, since everything looks good, I'm going to keep moving forward. What we're going to talk about here in a few minutes is, if I looked and saw something jacked up, I would turn and go back. Okay, so let's go ahead. Since it looks good, I'm going to hit continue. And you know me, Ray Gore taught me to wait for 2 pulses, so I try to as much as possible if there's enough load. So we got our first pulse. You'll notice at the bottom of the screen it says test in progress in red because we're still completing a number of pulses to complete the test, or time, whichever we've got it set up for. Then when it actually completes the test, it does show test complete in black at the bottom of the screen. Okay, so there it is for us, test complete, black at the bottom of the screen, 100.014. We can live with that. It fell within the range that we said was pass or fail because of the way we have this test kit set up. So we're okay and we can move on. So I'm going to hit F6. Okay, it always shows us that before a meter test or a CT test. So now remember, we just have A and C currents, right? So we're going to get a test on phase A and phase C here. So phase A looks okay. We've got 605 CTs here. So looks like we got a pass on A and a pass on C. Both of them pretty consistent. The numbers look really good, so we've completed that test. So then I would hit F6 to save and date and time stamp that test. Okay, so then if I want to go back and look at it, we will here at the end. We'll go to recall data. I can take a look at all these tests. Okay, so now we're going to go to the next one, and Chris Mullins is going to throw me a curveball. Okay, so ready to start the next one. So I'm going to hit integrated site test again, number 2. Glad to do anything here. We good on here, Mullins? Yeah, start. Likes the elbow, doesn't like the fingers. Okay, cool. So now we're hot. Okay, so let's go into number 2, integrated site test, just like we did before. Same thing. Everything is the same. We're not changing anything. We're just going to hit F6, start the test. Everything looks good. Y'all are seeing what I'm seeing, right? That's not good.
Was something wrong?
Yeah, something's definitely wrong. So A phase, it looks like on A phase, I have got polarity reversal on A phase, is what it looks like to me. So, and this is something we can think about for a minute. Here's where we're talking about using that head a little bit. What is it that has moved out of phase now? Let's think about it. Which of my vectors has swung around? Okay, my current vector on A phase has now swung 180 degrees. That lets me pinpoint, I think I got a current problem, so I probably got a problem on my CTs. Okay, so this is pinpoint, I've got a current problem here, so my current's 180 degrees out. So let's take a look at my, here's the point where I was talking about earlier. If I see a problem on this, and remember, if I've got one phase out, now this is where we got to think a little bit. If I've got one phase that's out, right, out of two phases, and I've got polarity reversal on one phase, it creates negative watts, right? So if it's a balanced load, I got negative watts and positive watts the same, I'm not going to have anything. It's going to be awful darn tough to get a pulse, right? You can stand out there forever. But we can confirm that because we want to see, is it on the secondary side or is it on the primary side? So that's where we want to make that determination, okay? And let's think about this for a minute. If you did if it was on the primary side and I did a CT test, I would still get a pass on that CT test, right? Because if I look at it, it's following, okay? So we're going to look at that right now. So let's take a look at that. So let's look at right now, I'm looking at this and I'm saying, I know that that's 180 degrees out. I'm going to hit continue. Now let's see if we get pulse. No. So we could be sitting here a long time waiting on a pulse, but let's try something else. Let me try, and this is what I was trying to tell you earlier. If on something like this, on a delta where I've got two currents involved here now, right? So if I see something like that, I know, let's just think in general, if I have any sort of polarity reversal with either one of those, I could sit here all day and not get a pulse. So let's go back and take a look at it just to confirm what we're saying. So I'm going to hit previous. And here I'm going to go to my power table right here. If I go to my power table, you notice over there, you can see how many watts I've got. Negative watts on A, and I've got watts on C for, I've got, where is it, 3 watts. So I've got a negative 3 watts. So is this meter going to do anything with negative 3 watts? Remember the little thing I said at the very beginning? Let's add those two things up. Number one, I only got 3 watts. Number two, it's not bidirectional. So if all I've got is negative 3 watts, I'm not going to get diddly squat out of that thing. So you can stand there forever waiting on a pulse. And after about 15 minutes, you'll probably call Red Gore and say, how come I don't have a pulse? So I'm just saying, we're trying to help out a little bit. That's what this is all about, right? So if we think about it, it is a delta service. I've only got 2 currents there. If one of them's flowing in the wrong direction, I'm canceling stuff out. I can stand there all day long. Okay? All right. So I'm going to prove this out of that. But let's go run a CT test. So we're going to run a CT test. So if I go right here, okay, we're going to go ahead and get to the test. So here we go.
So John, why did that pass?
Remember I mentioned that a little while ago. This is on the primary side now. Now I know. This is where we used all that forensics, right? And we got to the point where we said, wait a minute. If it passed this test, if the swap was on the secondary side, I would get polarity reversal, 180 degrees out, fail, fail, fail. But if it's on the primary side, I don't, because it's following, right? It's just following along with that same voltage. I'm following with that current. So it's saying, no, it's not seeing it off the primary side. If it was on the secondary side, I would get it right here. But because I looked at a few things, I looked and saw how many watts I've got. So I know something's got to be, right? Because I've got negative watts. So something is definitely reversed because of the number of watts, the watts that I've got being negative versus positive. So I know I've got that there, right? So then what do? I turn around and say, okay, it can't be on the secondary side now because I would have gotten a failure right there. So now I know someone's rolled something up there on the primary side. Okay, so you can just add all of the evidence together and come up with a conclusion and act on that. That's where we get on the forensic side of this, okay?
Mind explodes.
The mind. Okay, so I'm going to go previous on that. Oh no, I'll hit done to record. And I'm going to previous out. And wait for the next curveball. We ready? Okay.
Go ahead, trainee Jones.
That's right. I use my elbow, sir. All right. I gargled with hand gel before I started this time. All right. So we're ready to go on this next one. So we left all our connections. We're still same form. We're still the three-phase delta. So we're still here at this 5S. So I'm going to go ahead and hit integrated site test, just like I was out in the field. And we're going to next. Oh. All right. It would appear to the untrained eye that we have problems on both A and C phases now. Neither one of those look correct. So it looks like a polarity reversal on both A and C phases is what it looks like. So let's hit continue. So, what should happen here, folks? Let's think about this. If I've got polarity reversal on both phases, what does that create? Positive or negative watts? Negative watts. So I've created negative watts on A and negative watts on C for a total of negative watts. What kind of meter do I have? It's not bidirectional. So you can wait here as long as you want to, right? So let's take a look just to make sure. Previous. This is one of those where you previous out. And that proves out on our RMS table screen, right? Our hot screen that we can hit right there on the side of the screen right here, one of our hot buttons. So I can just hit that table and look at information. And if I look at my bold, which is my watts, which is so important to us, I've got negative watts on A, negative watts on C, for a total of negative watts. And that being not being a bidirectional meter. If it was a bidirectional meter, then we would get a pulse. But remember, this is similar to, and any of you guys been out there testing any kind of solar stuff or anything like that, you know that we can set up in the phantom load test. You know how we set up between received and delivered? That's what's going on right now. This is all received. We're not delivering anything right now, is what it's looking at. So it's seeing all negative power right here coming to us, okay? All this is negative. So what do? We say, okay, if that was a bidirectional, it would give us a negative % registration is what it would say here. Okay, so we would get a pulse. But in this case, without it being bidirectional, we won't at all.
John, we had a question in the chat.
Sure.
The gentleman asked about if you could see the vector diagram looking at the secondary currents and looking at the primary currents.
Absolutely. Absolutely, you can do that. And as a matter of fact, we're going to do that here in just a second. That's a great question. And when you take a look at the primary versus the secondary currents, and a minute ago when it was the primary, that was a great question. What you would have done was you would have seen it rolled on both, right? I would have gone back and went to my primary current screen and hit that tab, which I've got tabs at the bottom. When I hit primary, it would have showed it rolled on the primary, and then we know that if it rolls on the primary, it trickles down and comes over to the secondary. We get rolled also because these connections up here are correct, right? So that's what it would have showed. It would have showed polarity reversal both on the primary vectors and on the secondary vectors, okay? That's a good question, thanks. So here we see that we've got negative, and since this is not bidirectional, we know we could just sit here forever. So what we're going to do is we're going to, we'll test the CTs. We'll do number 4. And we'll go CT test number 1. And we'll go ahead and test. Now, what would we expect to see on this? We have polarity reversal on both of them, right? The machine knows. So it gives us a fail. Since we have both of them that way, it's also going to give it to us on the C phase. So when we test C phase, same thing. Notice what's in red. We always say follow the red. You get a red fail, follow the red numbers and see what caused it to fail. You can see both of them are 180 degrees out. Okay? Which is what it showed us on our numbers when we looked before and saw those negative watts on both A and C phases, right? So I'm going to go continue. So with the setup we had, knowing this is not bidirectional, knowing both of them are cross-phased by our vectors, we looked at the vectors and saw them cross-phased, we looked at our numbers, got negative watts on A and C phases. Unfortunately, we're not going to be able to test with this meter because it's not bidirectional, so it won't register for us. Okay? So I'm going to go back out and wait for my next curveball. Okay, so we're back on the same service. This 5S Delta right here, 3-phase 3 wires. So we're going to go ahead and hit number 2. So we're going to hit and continue. And we're going to continue again. Okay, here's what I'm seeing. Tell me if you're seeing what I'm seeing. I'm seeing A phase polarity, looks like polarity reversal on A phase, and C phase is now flopped from being horizontal. It's like it's flipped 180 degrees from upper quadrant lower, right? So it's just kind of rolled down below like that. Okay.
What should the vector diagram look like?
Yeah, and this is where someone had asked about this. Well, they didn't ask about it. I really wanted to show this. Let's say if you see something really crazy like that and you go, man, wait a minute now, what was it supposed to look like again? So you can previous out. When you get to this screen right here, if you hit your vector button before you get into the test, you can get this, and you see over here on F1 it says reference. I can hit that reference button and it will show me. And by the way, someone was asking before about that. Here's that secondary versus primary button right here. Okay, so I'm going to go over right here and I'm going to hit reference. Oh, so that did happen. Then the C phase just rolled down to the lower quadrants, right? It just rolled over, and my C phase definitely, all right. See? So it looks like it's rolled A phase, rolled C phase. A phase looks like it's got polarity reversal. So here's where we got to think a little bit about the meters in that and what they use as a reference and where they gain their power from. Remember we mentioned that the other day about the gain of the power. It was the lance and gear was off C, whereas most everybody else was off A. What do these meters use for their reference? What phase are they using? They're using A phase as their reference, right? So if we look at this, A phase right here looks like it's 180 degrees out, and then it's rolled. All right, let's go ahead and hit. Let's go previous here. All right. I would guess we're probably not going to get a pulse. I think we're running the same situations that we had with some of these other error scenarios we've shown when it comes to a delta, right? We're only dealing with 2 currents here. And one of them is completely flopped. All right, hold on a second. Let's get out of this. Let's see if we can test the CTs. So far what it looks like is something has happened on A phase. Whatever's happened on A phase, it has actually caused my C phase to rotate around. So it's had an effect on C phase, whatever's going on A phase, right? Both of them pass. So what did we say before on a pass, on a polarity? If I see polarity reversal on the screen, what looks like polarity reversal, but I get a pass on my CTs, that tells me it's on the primary side then, right? Because it was on the secondary side, a polarity reversal, I would get a fail, right? But I didn't get a fail. So this is telling me that whatever issue this is, it's on the primary side with A phase, and whatever the problem is, it's caused me to have it actually took those vectors on C phase and rotated them down, right? So that's the problem I've got. And since this is using A as a, I would say what we need to do is we need to check out the primary current on A phase. What do you think, Miles?
You think so?
Yeah, that's what I would say.
I got that pass fail button ready to go.
Oh, really? You ready to put pass or fail on it? Well, hit it, because that's what I would see.
You think it's A phase current?
All right, let's stop and think about this for a minute. All right, let's think for a minute. Yes. Yes, because of the way that my current had rotated over my current moved. Yes. That's what I'd say. All right.
What's going on is that the A phase voltage PT has a reverse polarity error. And when you reverse the polarity on the PT side, everything flip-flops because the reference always stays at 3 o'clock.
That's right.
And so everything has to flip-flop to accommodate that
That's right.
phase shift or phase error.
I didn't know we had PTs. And that would totally make sense. Because it's ruined my reference. It's ruined my reference voltage.
Right.
Okay. That would totally make sense. Okay, so if we had PTs, that would totally make sense. Okay.
Good try.
Well, I didn't know we had PTs. All right. Okay. So let's hit done. Okay. At some point, are we going to go to single phase now? Or
Yes, we're going to single phase.
go to single phase? Okay. All right, so now we had a request for this, so we're going to go to single phase with this. All right. So if I choose, I've got a, let's see, I deselect the site, so I can choose another site in here, which we've got 12S single phase. There we go, we got 5S single phase.
So some of our users know that a 5S can accommodate multiple service types out there. With this test bench we have, we're able to drive a 3-wire delta, and we're also able to drive the single phase 3-wire. So what we're showing here is a single phase 3-wire service. And the only real difference that John has to make is that on a delta, the way the phases we references are A and C, and on a single phase service, we're using A and B in this case. Brent had a question about using a 4-wire delta with 2 CTs as well. Yes, we've seen that in the field. I don't have that simulation enabled yet, mostly because of the CT on A and B are wired a little differently. They kind of crisscross each other to kind of sum up. But yes, that's another good example we see a lot, and especially the older industrial sites that have that. But yes, you're correct, Brent. A 5S is probably the most universal meter out there.
All right, so we're connected up for a 5S single phase. So everybody sees the changes we made on the connections now. I've got B over here, right? So I've got A and B, and I've got also B over there, okay? Cool. So first thing we'll do is run a test, because I'm guessing the first one, unless he throws me another curveball, first one should be a normal setup, but we'll find out. Color diagram. All right, now.
Thanks, Ed.
Got my elbow ready to go. That's what we're looking for. Everybody see our vectors now, right? You see we got A, B, we got our current on B, we got our reference voltage over there, so we're good. So we're going to go here. Look for our pulse. I broke Ray's rule, but it's for time's sake, Ray, in case you're watching. So our numbers look good, 100.037, 056. Test complete, it's awful darn good, so we can live with that all day. So we go next. So we had 2 passes, so we look good. So that they must have given me the normal setup because I didn't see any crazy curveballs. So that would be a normal setup on the single phase 3 wire. So now let's I'm going to hit time. And now we start with the curveballs.
I'll give you a hint on this one, John. You may want to toggle back and forth between your secondary vector and your primary vector.
Ooh, okay. Then we'll do that. Okay. So we've got leaving everything the way it was. So we're going to go into integrated site test again. So we're going to hit. Whoop. Okay. Okay, so looking at this, should be my secondary vector. It's looking like I've got my current. My A phase current is swung over as with the B phase current, right? So I've got 180 degrees out. My current has swung over from where it should be over here near my A phase voltage. It's swung over here to my over to the left over here. So you can see it's about 180 degrees down on that. Okay. So now, well, this is going to probably fall into the category of what we said before, right? As far as if I've got something like this and I've got polarity reversal, chances of me getting a good pulse are pretty slim, right? And then couple that with the fact I don't have a bidirectional meter here, so I'm going to have a problem. So let's go back, and I'm going to preview out, and let's take a look at these vectors. We're going to do that to what Chris was saying. So let's hit our vector button. Remember, once we back out of it, we can hit the vector button. It gives us all those good buttons at the bottom with our vectors. So let's see what a reference looks like. So we see that we're 180 degrees out, like we said before. So let's get over here and look at our primary. Did we see any change? Yep. Right? So now when we look at the primary, it's swung over here. So everything is swung over where it should be. Right? So now I go over here to my secondary. Hit my secondary and it swung back over there. Right? So I am, according to this, and where will be the last little piece of the puzzle that we do? Let's go ahead and test the CTs. Let's test those CTs and get what we get. That ought to tell us for sure. So let's go back here and test the CTs. So I'm going to do number 4. And I'm going to test just CTs. Because remember we said before, one of the indicators for us between there being a problem on the primary versus the secondary, we know if we get a fail on our test here, our ratio test, on that secondary side, get that polarity reversal and get it 180 degrees out and get a fail, we know the swap's been on the secondary side versus the primary side, right? So let's take a look here. Okay. Fail at 180 degrees out. So I'm saying that we have our, we get a pass. So I'm saying that we have polarity reversal on A phase secondary side is what I'm saying.
Very good.
Okay, cool. All right. And you saw how we did that, putting the pieces together to make sure it wasn't primary versus secondary. To what Chris said earlier about flopping it. Okay, when I flopped it, I didn't see the problem on the primary side. I just saw it on the secondary side. If you look at it and you see the problem on both the primary and the secondary side, when you flop between those buttons and look at it, and I got polarity reversal on both, then I know the problem's on the primary side. Okay? All right, so I'm going to hit done here. So we can save that test, right? Date and time stamp it. So my previous, back out to the beginning. Wait for another yacker for those baseball fans out there. Isn't that right? Oh, where'd he go? Mitch left. Don't they call a curveball a yacker?
Mm-hmm.
That's what I thought.
Yakker's a bird.
Yacker. All right. Do you remember the fellow's name that asked for the 35? Yes. Before we read, that's not telling thank you. Okay, we're asking back. Okay, so we're back again. We can see we're hot on this one, so we're good to go. So we're back on the single phase 3-wire, right? So we're going to hit our integrated site test. And going to hit next here. Okay. So what does it look like now? It looks to me like we've got polarity reversal, and tell you what we do. Let's go back and let's look at the reference. So we go to here. As long as we're not in the test, we back out, we can go to our hot vector button and we can look. Okay, so there's what we got versus reference says, Okay, so we see the difference, right? You can already see this difference. Make sure we're wiring again. And that's it, primary versus secondary. See if there's any change there. Have I moved? Oops. So everybody's seeing what I'm seeing, looking at this, right? So it looks like I've got it looks like I've got my vectors on A are they're 180 degrees out, right? And then I've got my my B vector is over in the wrong quadrant too, is what it looks like. Are y'all seeing this? Okay, so let's go back here to reference again. See, my reference should be, I should have my A's over here to the right and my B over here to the left. Let's look at it one more time. So I've got B to the right instead of the left, and then I've got my A phase current is to the left, right? So let's go ahead. See if we can pulse. So what's the consensus out there? Do we think we'll get a pulse or not get a pulse? Can't hear y'all.
They're yellow.
Are they yellow? I just can't tell them as he sprays down the Lysol. Oh, is there a delay? Oh, my bad. I'm sorry. I'm sitting here going, come on, man. My bad. Okay, so there was a delay, sorry. So we're not getting any, so right now we're not getting any pulses, which we would expect, right? When we start having, we're only dealing with two here, right here, so we can't get, I hope y'all will stay with me on this one. Okay, so if we only got two currents we're staying with, and those are opposite, they're going to cancel one out. If I got a third phase, they could give me some sort of watts to where I could get a pulse, I might get one. When I'm only dealing with two, and they're canceling one another out, I'm not going to get anything. Okay, so in this situation, I would expect probably not to get a pulse. Okay, so what I'm going to do now is I'm going to preview this out. Let's go back, let's test the CTs. So it's seeing it as a polarity reversal, right? So let's think about this for a minute. So both of what the machine is saying is it's saying that my B phase vector was 180 degrees out. It's saying that my C phase, that my vectors, on A phase are both, they're 180 degrees out. You know what it looks like to me is if I've got both of those like that, the machine will see it. If I cross phase A and B phases on this, this is how the machine's going to see it. The machine's going to think that it's got polarity reversal on both of them because they're going to be 180 degrees out, right? So it's going to see this as just what you're seeing right here. So I would say, I don't think they're both. I think what you've done is you've got A and B phases cross phased. Is what I'm doing.
Correct. Yeah. On the secondary side, the A and C in the first phase and second phase were swapped coming out of the CD secondary itself.
Gotcha. Okay. So it all makes sense. That's the way the machine would see it. We use a little bit of this, and we can figure it out, right? Okay. Let's see. Time. Okay. ready for the next one?
That was last one.
That's it? Oh, okay. I hope you guys have picked up a few things on this in that it takes everything we've got, right? We got to use these. We got to look at what we're seeing here. We got to think a little bit. I mean, now I'm dealing with just the two currents. If one cancels out, that way I'm not standing there for 30 minutes wondering why I don't have a pulse and then calling Ray on that or whatever it is. I mean, let's think. If we think about it a little bit, not only think about the meter that I'm testing, think about that service, how many currents I've got. If one's out of phase, it's going to cancel the other one out. I'm not going to get pulses. That's why I'm not going to get, I'm not getting watts, so I'm not getting pulses. If we think about those things when we're out there, I mean, that's why they need us. Is we can see a problem, the machine will tell you got a problem, and it'll do everything it can to tell you what the problem is. But there's no substitute between here, no substitute for experience, right? So be careful out there.
One more question.
Yes, sir.
Marshall asked, what's the effect of voltage and current harmonics on metering accuracy?
Oh, I get asked about harmonics a lot, and I know that's what I know that ANSY's been keying on that for a little while now. I'm not sure what's going on now with all this, everything that's been going on, but for a while that was one of the hot buttons for them because for us, our test kits can read up. One can read up to the 50th harmonic, this one, the other to the 100th harmonic. I know that's been the hot button to them because what they're going to ask us to do now to the meter is we're going to ask to provide these chopped off, crazy looking waves as a test kit to run through the meters, and we're already working on that stuff. So I know because what happens is when you apply the harmonics on there and we get all these chopped off waves instead of these nice pretty waves, to be honest, I'm going to let you try and answer this.
It's a good question.
Yeah.
From my experience, the meter actually handles those voltage and current harmonics fairly well. What does not handle harmonics well are the CTs.
Okay.
The CTs do seem to break down over time, especially with high harmonics. And when I say high harmonics, I'm talking something above 20% THD or more.
Okay.
I've seen that in principle. Seen a CT break down over a couple years, and you start getting a failure from the CT itself. So it's not instantaneous, but it's a long-term problem that will continue to get worse if not corrected. Another big issue we've seen is if there is a presence of the third harmonic, that will triple the current on the neutral phase. Why is that a big deal? Typically, you're going to have a lower gauge wire of the voltage neutral coming in as opposed to a higher gauge wire you have for the phase references. So if you have an amp on A, B, and C, I've got 3 amps on neutral, and that wire is not meant to handle that amount of current.
Gotcha.
So therefore, you have a breakdown on the neutral current phase that would be a very, very dangerous situation if you lose a neutral phase on the site. Also, you have no reference anymore, and therefore your metering is
Gotcha.
inaccurate.
Aren't the two numbers, Chris? I know for voltage it's 8% or more.
We recommend 10% or less, not
Really?
a problem on voltage. 20% or less, not a problem on
Current, that's what I thought. Well, the ways I always remembered it was because I'd asked somebody, and they had told me 8%. In my P brain, the way I remembered it, V8. The juice. So voltage 8, anything 8%. Chris is saying 10. I'd asked an engineer. They said 8. So anything 8-10% on voltage, and then any 20% or worse on current is going to be bad. Okay.
One more question that came in from
Yep.
John. He is asking why use a 5S for a single phase service rather than a 4S? Good question.
Yeah.
There is no particular reason.
No.
I think a lot of utilities, to try to minimize the amount of inventory they have, they buy a whole bunch of 5S meters and 5S
Use them for
sockets,
everything.
and they use them for everything.
That's right.
Yeah, that's the only reason. You're right. There is no logical reason
No.
why you use a 5S versus a 4S. 4S is actually cheaper.
Yeah, it probably.
But good question.
Yeah, less stocking, so it always comes back to this. So, was that pretty much all the questions? Cool.
Yeah.
All right, good. I like answering the questions. Okay, really appreciate you guys tuning in. Just remember, we're going to be keep on doing them every Tuesdays and Thursdays, 11 o'clock. If you have anything else, thanks for the suggestion we had today on showing the single phase 3-wire on the 535. So if you have any other suggestions like that or anything you'd like to see, Also, we were going to show the high volt probe today. Someone had asked about seeing the high volt probe, but I will absolutely have the high volt probe next week to show you guys next week. Okay, as a matter of fact, I might even show it just a quick showing how to do it on Thursday, and then we'll go into the other stuff we're going to talk about on Thursday. But either way, coming up, you'll see the high volt probe in action shortly. All right, so once again, God bless and be careful out there. All right, thank y'all.